In this video, we will learn how to add rational polynomials. But first, let's recall adding fractions that do not share the same denominator. For a general case, we see a over b plus c over d. Our first step is to find a common denominator between these two fractions. Here we will have a common denominator of b times d. In order to get both of our fractions to share this denominator, we will need to multiply the denominator of the first fraction by d, but since we can't change what the fraction is, we will need to write it as d over d. So we are essentially multiplying by 1. Note, multiplying by 1 does not change the number that the fraction is, because 1 is the multiplicative identity. We can do the same with the second fraction by multiplying by b over b. Once we expand, we will have AD over BD plus BC over BD. And in one final simplification step, we can now, since we have a common denominator, write everything in one fraction. Although the rational polynomials will look different than this, it's important to remember that we are going to follow the same steps to simplify our rational polynomials. Here's an example. X over 3 plus y over 4. Our first step is to find a common denominator. Here, our common denominator will be 12. So we see we need to multiply the first term by 4 over 4 and the second term by 3 over 3. Again, we're only multiplying by 1. We're not really changing anything, just the way it looks. Now we see we have the same common denominator, and to simplify, we'll write it all as one fraction. Here's another example. 3 over x plus 3 plus 2 over x minus 2. Again, let's find a common denominator. In this case, our common denominator will be quantity x plus 3 times quantity x minus 2. Here we have us converting our fractions into the common denominator form by multiplying by 1. Now we multiply the numerators and denominators of each, and we see that we have our common denominator. We can now simplify, write it all as one fraction. Now, in this case, we're not done yet. We still need to simplify the numerator. In order to do this, we're going to expand the numerator and then combine like terms. There's the numerator expanded, and now in one final step, we can combine like terms and see that the numerator simplifies to 5x. Make sure to simplify all of these fractions completely. Let's look at another example. X plus y over xy squared plus 3x plus y over x squared y. Again, we're going to find a common denominator. In this case, the common denominator will be x squared times y squared. So the first term is missing an x in the denominator, so we'll multiply by x over x. The second term is missing a y in the denominator, so we'll multiply by y over y. Remember, we're still multiplying by 1. Now, if we multiply those together, we get an x times the quantity x plus y over x squared y squared plus y times quantity 3x plus y over x squared y squared. We have our common denominator. Let's write it all under one fraction. And again, we'll expand the numerator and combine like terms. There's the numerator expanded, and after combination, we see this. X squared plus 4xy plus y squared over x squared y squared. Now, we can't factor the numerator, so we'll leave it as is, and this is the simplified form. Here's a final example. Here we have two fractions with polynomials in the denominator that are not factored. So our first step before we can find a common denominator is to factor these polynomials. So here I've factored the left one as x minus 4 times x minus 2, and I've rearranged the right one so it's easier to factor. In this step, I've factored out a minus 1 so that I can now see the polynomial and factor it. Here we have everything completely factored. And we can see that our denominator, our common denominator, will have to be x plus 1 times x minus 2 times x minus 4. The first term is missing an x plus 1, so we'll multiply by x plus 1 over x plus 1. And the second fraction is missing an x minus 4, so we need to multiply by x minus 4 times x minus 4. Once we do that, we see that we have our common denominator. Remember, the order of the terms does not matter with multiplication because multiplication is commutative. Now, let's do a step where let's get some more room first. And now we're going to do our step where we put everything under one fraction. And now we must expand the numerator because we're not fully simplified yet. Expanding the numerator gives us x squared minus 1 plus 2x minus 8. And we can combine like terms to get x squared plus 2x minus 9 all over that common denominator. As you do these problems, it's important to remember that even though they look more complicated, all we are doing is adding fractions. So, remember to find a common denominator and simplify fully.